The last time I was invited to give a talk on this program. I just snuck it in under 4 hours, and I only finished it in 4 hours because the sausage rolls were getting cold at the back of the room. So you guys should be okay. You've got 25 minutes to put up with me, and then that'll be it. Okay, 13 billion years ago, we had the Big Bang, chemical reaction, and the universe was invented. 12.870 billion years later, we had dinosaurs prancing around the place until a big meteorite killed them outright and virtually everything else on the planet. About 150 years after that, we had first of the simian culture of apes starting to stand upright and being our forebears. 3000 BC, the Egyptians were the first ones to start associating objects with words, and we had the whole concept of writing and recording information in that way. 1850s, a guy called John Snow is attributed with the first GIS, let's call it incident example, when he mapped cholera outbreaks in London, and he discovered that the locations were distributed along the shores of the Thames. So he concluded that cholera was a waterborne disease, not an airborne disease, as was expected, as was thought, and how people were trying to treat it, and he was right. And then he mapped the bore locations against those incidents and also concluded which bores were spreading the disease. Okay, 1840s, computerization, that's 1838 to be exact, the first computer. 1970s, GIS started in its early form, and then we've had a few decades of the technology evolving and lots of conversion from hard copy into electronic. And now we have where we are today. It's about integration. To me, it's all about data integration and systems integration. I know that's a long way of getting to my point, but that's kind of where I'm going with that. These are fantastic slides, but we're on to this one. So more and more these days, utilities are talking about OT. IT is the boring stuff. It's HR, payroll, technology like that. OT is operational technology. So I'm talking about GIS, SCADA, the real-time, and asset management, the real meaty stuff. And the definition of OT being technology which involves a change of state of the asset. So more and more, people want to be a digital utility. So what does that mean? We're talking about information be captured electronically at source in the field and flowing through the organisation, being processed, worked on, etc., and then ending up in the various key asset repositories, meaning GIS and asset management. There's a lot of work required to do that, and that's not something you're going to do overnight, but that's where utilities want to be, without a shadow of a doubt. So you've got digital asset management, digital customer management, etc., etc. So there is quite a lot of work and there is quite a lot of change to make that happen. It really is. But it's only going to happen over time. So to make it happen over time, people need some sort of strategy. Strategy, plan, call it whatever you like, but more and more these days, utilities are having digital strategies, not just in the GIS space, but right across the enterprise. Like I said, call it plan, strategy, whatever, it doesn't matter. And it doesn't matter if it's on its own and maybe incorporated into other strategies, but an approach to get the company from where it is now into having more and more digital information so it can do more things, analyse more things, be smarter, make better decisions, all that sort of thing. Okay, so first of all, to make all this happen, you need a vision. Years and years ago, when I was doing my early days of consulting, I would have said that sounds a little bit like a bit of bollocks, but it's not. I go around the country in so many different utilities and I see people chucking in systems, pretty good systems, flash systems, Esri systems, and I see them failing as well. Failing or just not succeeding nearly as much as they could. My point is that people need a vision as to what you really want to do, and what you want to do is not just chuck in a GIS system or an asset management system or whatever, it's do something with it. For example, so many of my utility clients, they want to click on an asset and get all the information about that asset. They don't care if it's in GIS, if it's an asset management system, drawing management system, document management system, doesn't matter. But the concept is they want to click on that asset, get that information, and be able to rely on it, and not have to go and search and spend ages trying to work out, is that the latest and greatest and the most reliable bit of info or not. That sounds simple, I know, but hardly anyone in this country can do that easily. So fundamentally what we're looking at is people want a single interface to data. GIS is an ideal interface, of course, because it does spatial and non-spatial information. So it's just kind of common sense. What I'm talking about is if you want to do something, we need to have a clear vision as to what we want. We need to go away and define our outcomes as to what that really means. And we've got some examples there, I won't read all through. And then after we've done that, you can work backwards and go, what projects and what initiatives do we need in order to make that happen? Pretty straightforward, really, but us consultants like telling everyone all the obvious things because that's what we do. Okay, so that's kind of the background to ADMS, which is what this program's about. ADMS, Advanced Distribution Management System. Basically is a combination of SCADA, DMS, which is Distribution Management System, OMS, Outage Management System. It sits on a GIS, which I presume you understand what that means, and a AMS, Asset Management System, dial into that, usually. Does a whole bunch of things, and I'm not going to go into it a lot today about all these great things because we could be here for ages, but this slide explains it in great detail, but we're not going to look at that today, but it does. The case study. Okay, which is the point why I'm really here. ActewAGL, which is not ActewAGL anymore, it's now Evo Energy because it sounds greener, I think. I think that's the official reason. They had an operational systems replacement program. And just to give you a bit of history, it didn't just happen overnight. We were got in 1998, to do a review of their CAD system and their data, which is basically schematic. And to cut a long story short, we eventually turned that around so we could go out to a tender and purchase Esri and fix up the data and all that sort of thing, but still pretty fundamental. 2006, it's kind of unfortunate being a Kiwi that I have to say the number 6 in Australia so often, but you know the word, you know the number I'm kind of trying to say. This exercise was involved, we identified the key business functions right across the business, not just GIS, but right across. And we scored each one of them, which is what you see, the light blue there for each of those bars is a scoring. We'd use a whole bunch of about 70 odd criteria in terms of data and systems and performance and all sorts of things. Those colours on top of those blue, on top of the light blue, are the projects or initiatives required to bring it up to best practice. Anyway, we did what I thought was a pretty cool exercise, and the business liked it. And I was presenting this to the executives in the boardroom, which is now the training room, so a few years ago. And I always remember it because I was in full flight, prattling on about all this stuff. And then the door opened, and this guy came in and straight away started questioning my lineage, which was quite at odds with the fact that I had 2 parents at the time. And he didn't sit down, he just stood there and basically just said that it was all bollocks, really. I'll use the polite word. He said, we haven't really got a data problem, we haven't really got a system problem. The thing is that the network was gold-plated. It was over-engineered. So for a long time, those managers could sit on their bum and do absolutely nothing, and the network was pretty good. But now the failure rate has started to go up, and their return to the shareholder has started to go down. It was still a hell of a lot of money, but it was going down. So that's where he and I differed. So 3 years later, the CFO was now concerned about their shareholding value going way down and the failure rates going way up. And as most of you must probably know, it costs about 3 times as much to be reactive than it does to be proactive. So managing an asset makes a hell of a difference if you're actually on top of it. So we did a whole bunch of things and did a data inventory across the business and all sorts of things like that. And about we sat down with Esri and had some sessions on where is the utility of the future going, what does that look like? And I spent a bit of time in the States and talking to various utilities and that. Basically that formulated, that was the plan for this program. That was the guts of it. We needed to align the GIS with all the other company strategies because senior management like it when you show them diagrams like that, so we did it. Okay, so this is a enterprise architecture diagram which is compiled off the data work we did. And basically, I know you can't read it that clearly, but that's kind of done deliberately really, but overall, the green boxes around the outside are the business units of the organisation. The blue boxes within that are the key systems, and the light brown washed out colour ones in the middle, that's each individual key data set. And the top left blue box, and all those lines coming out of it, that's Excel. This diagram, more than all my words and anything else, scared the hell out of management. Totally. They thought their data management wasn't that bad. They thought most of the information was in corporate systems. It wasn't. So more than anything else, that kind of said where we're at, and what we're trying to do is change that. So when you are tracing through a network, we need to trace completely through the whole network if you're doing an ADMS project. Can't have partial connectivity. But it's not just 100% connectivity, you need connectivity through everything. Like if you go up to a substation can't be a circle or a square, can't be a symbol. That is a world unto its own, and then you need to be able to trace down into that world completely. So you can go through the bus bars and the transformers and the reclosers and close them, open them, do all that sort of thing. They didn't have any of this, so we needed to do it. So just in summary, what we needed to do was to upgrade Esri because we were going to implement about 5 different systems and they all were going to plug into Esri, and they all needed the latest version of that in ArcFM. Our asset management system was old and unsupported, so we needed a new one of those. A SCADA system, we decided wasn't consistent with our roadmap going forward, so we're going to replace that. And our design was manual and automated, so we were double entering in GIS and in CAD, other way around, CAD and then GIS. So we wanted to put a designer, which is a third-party package, plugs into Esri and goes on the front end, so we're designing direct into the GIS. On the data side, I mentioned the internals. We have to have an internal project. Our data wasn't good enough for an ADMS, so we had to have a field data capture project. So that was quite a biggie. The other data, the standard SCADA, our GIS data just wasn't good enough to be a SCADA network, so we had to have a data improvement project. We had 3 different representations of the network model, meaning one in SCADA, one in GIS, one in load flow, one schematics. Well, we needed one of those. So that was a key thing to do, to achieve. Data improvement project at the end, we had unit assemblies. Just to explain that for those who may not be aware what unit assemblies are, instead of just building a transformer and getting all the parts together, you choose transformer A, B, C or D, and in doing so, with any of those choices, you get a whole bunch of components all put together, already set for you, all pre-done. So it's effective, it's efficient, and you're standardising your network. So later on, when you take a component and you change its asset life, you either make it smaller, larger, whichever, you then can do that with your components right across your network. It's a lot more effective. Okay, so that's the rationale behind it. Another good slide, but moving on. So basically we had senior management support, and our GM was slightly demanding. I'm not sure if I can say slightly crazy, but he was the key person for this. So we had 9 project managers. We set up 9 project teams. Went to Europe and engaged a guy to be the project manager of the ADMS implementation because he had implemented the system we purchased. We wanted someone who'd done it before. We had enough risk with all the data projects we had to have, we're going to do, so we at least wanted to more have the confidence in the technology side. Then obviously we put a lot of effort into change management, but not as much as we should have, but I'll get to that at the end. So that's like an org chart. In our program board we had the CIO, 2 GMs, and we met once a month. I had a program coordinator, and she was absolutely gold. We had representatives of every business unit that the project touched on, which was all of them. And then we had projects for, as you can see, one project for the GIS, for the ADMS, for data improvement, for billing, for asset management, for field data capture, unit assemblies, and business process development. That's 9. So just briefly, our key systems, the key projects, implementation. We had an Esri upgrade. We're implementing Designer to go on the front of Esri. We're implementing CityWorks as an asset management product. Implementing Riva, which sits on top of CityWorks for, it's called SAM, Strategic Asset Management, or Advanced Asset Management product. Implementing Schneider, ADMS, and a Gentrack billing system. And then decommissioning all those other systems at the end. The data model. I know Neil's here somewhere today. Neil and Bob did an amazing job of this. It was challenging as hell. It was huge. Because what we're talking about here is we had a GIS with a data model, an asset management system with a data model, a SCADA system with a data model, an outage management system with a data model, and we needed one. You're either going to try and combine all those and do bits and pieces and get common fields, or just have one. In this case, we did one. But it was a hell of a job. And I know we made it really hard for Neil and Bob, because we tried to chuck everything in there, and that was a bit of a mistake, because this thing was so massive anyway. And yeah, lessons learned really. It has to be good, but yeah, like I said, and once you've got the data model, you then have got another exercise of aligning all your data to the data model. That's even bigger. So just pictorially, something just gives you a rough idea that ADMS is in the middle, a whole bunch of other systems are coming off the end of it, and the top sort of left are the smaller SCADA systems which all need to interface with all this. I just like showing this because I did it, and I don't, being a consultant, I don't tend to actually do many things, so I think it's quite pretty. System dependency was huge. If you've got 9 projects going together, and both in terms of technology and scheduling, there are a hell of a lot of differences, and one change in one project affects the others. So every week we needed to adjust our program and our schedule, and that was challenging. Maybe that doesn't look too complex, but believe me, it is. It really is. So on the data side, data projects, we had a project in GIS improvement, a connectivity project, an internals project, unit assemblies, building the data model, a field data capture, which involved getting a large amount of people in there to get information like phasing and all that, because you need phasing for an ADMS or you can't, or it doesn't work. And SCADA connectivity, which we contracted to an Indian company. And of course, at the end, we needed to redevelop a whole heap of business processes to make all this work. Connectivity needed to be 100%, 100.00 to be exact. Not being too dramatic, but we're going to take over the SCADA system and provide a GIS system which would 100% in real time replace the SCADA system network, and you can't really get it wrong. So we started off with about 3-4 different representations of connectivity around the place, and ended up with one. And I will always remember the day, we were building up to this, but the day when we were calculating where we're at in terms of, you know, the figure is 100.00, but where are we at? I always remember that day thinking, you know, If there's a fire alarm, I'm not letting them come out. If there's a fire, I'm not letting them come out. If someone dies, I'm not letting their ghost come out. I want them to come out of that room with the right answer, preferably 100, but if not, close. And we finally got it. And like you need it, you can't get around it. So it's pretty satisfying that the SCADA network is entirely 100% driven from the GIS, which means you've got to have processes in place to make that happen. Okay, so now with this ADMS platform, the next project we started was an EV project, electric vehicle. So we went to Israel and got the world's best EV software. I won't say what it is, but it's pretty cool. And built some chargers all around the ACT. So now the ADMS system is the key system, because you can't let people go and charge their cars at the expense of your key customer. So if you've got demand and then you want to decrease the extent to which you're charging your cars so you can still let your key customers do what they do, all that sort of thing. So this whole technology, this whole ADMS technology has given them so many more options. Time-wise is going. Okay, key outcomes. I won't go through any of them other than the top one. One single source of truth. And I can't help but smile when I say that, because the project stands or falls on that. You walk into that room in Canberra now, and that's what it is. It's all data entered in the GIS for all those systems. There's a whole bunch of other benefits, but that's the bottom line. Full synchronization between GIS and asset management, all that sort of stuff. We underestimated the amount of QA for data. We knew data was going to be huge, but it still took a long time to get it right. So we underestimated the amount of time it would take to build a LV SCADA network to get that right. Still within contingency, but we still underestimated it. So I don't want to build this up as the perfect project. It's a million miles from that, absolutely. We learnt a lot. I think we achieved quite a lot, but it wasn't smooth. It really wasn't. It was a hell of a challenge, and some people came out of this really well. There's some young guys and girls at Actu who came out of it, and now they're quite senior managers because they just absolutely excelled. And some people had to let it go. But it was cool. There's still more things to do. Just finishing off, it's kind of like, I'm not saying they're done, because they're not. The other bits and pieces there, I won't go through them, but man, are they set up for the future? They really are. That's the digital utility. That's integrated enterprise integration with one data model, no duplication, and to me, that's where people want to get to. And I know this is a GIS forum, so we sort of, do the obvious and say GIS is the middle of it, and it is, because every bit of that technology is all hooked up to the GIS. Every bit of that data quality is all in terms of the GIS. And that's it. Cheers.